Hello, welcome to GitHub. My name's Dinah. I am an engineer here. I forgot how to make my picture a circle, so you don't know what I look like on the internet. But you can find me on the internet at Dinah She. I work on the GitHub Packages team here at GitHub, which, like I just mentioned, is in public beta. It's really exciting. Let me know if you want to talk about it after, but that's not what this talk is going to be about today. I'm based here in San Francisco, which means I get to play host for all of you today as if I had anything to do with this evening, setting it up. I didn't, so if you have a chance later when we're doing that social thing called mingling, please take a moment to say thank you to the organizers, as well as Brian. He works really hard on our developer relations team here to make events like this happen, as well as humanize GitHub in the eyes of developers every day. So I would tell you to buy them a drink, but I'm pretty sure the drinks are free. Yeah. Right, so you're welcome. Okay, so this year I was lucky enough to attend GraphQL Conf, and GitHub was a sponsor there. So I got to the venue, and I met a couple of my coworkers there who I'd never met before because GitHub is so into the remote distributed thing. And we were setting up this booth and kind of just chatting about GraphQL, about what it's like to work at GitHub. And we don't work on the same team. We don't necessarily interact with each other super often, but we do work on the same code base, so a lot in common. And what was really funny is a couple of themes came up as we were having this discussion. One of them was like the authorization story. What's that like here at GitHub? How can we make it better? What's going well? Another piece was rate limiting. Another piece was kind of preloading and server efficiency. And then literally 30 minutes after that, in the opening keynote, Dan Schaefer talked about how GraphQL was built to solve a certain set of problems at Facebook, and as a result, didn't solve a certain other set of problems that Facebook had already had solutions for in other services. And these four things that he mentioned were authorization, server efficiency, results caching, and rate limiting. So literally 30 minutes before the opening keynote, my coworkers and I were kind of just talking about GraphQL at GitHub, and we hit most of these points. So if you haven't seen this talk, I definitely recommend checking it out. It's really cool. It gives you a lot of insight into how Facebook solves these problems and why they weren't kind of built into the GraphQL spec. And as a result, everyone who implements GraphQL kind of has to figure it out on their own all over again. Today, my talk is going to tell you how GitHub answers these four questions. It's not necessarily meant to be like a step-by-step tutorial by any means. I'm sure if you talk to engineers here at GitHub, we'll be the first to admit that our systems are not perfect, our processes are not perfect, but maybe this will help spark some ideas in your mind about how to bring it to your company, to your side project, or maybe you're just really curious what other people are doing. So to give you a lay of the land, I want to introduce kind of GitHub stack to you. If you're not familiar with our stack, we are a Rails shop. We're very invested in Rails, and as a result, we write Ruby. We are still a monolith, which means that every single day, a couple hundred engineers work on the same code base, so you can bet that's fun. And we, like was just mentioned, we were kind of the first big company to adopt GraphQL outside of GitHub within industry, and that happened in 2016. So in the 3 years since then, a lot of industry has started to adopt GraphQL, and that's really exciting to see. But GitHub is still one of the only companies at its scale that has a public GraphQL API. So in a lot of ways, even though 3 years have passed, we still face a lot of very unique problems that GraphQL doesn't really solve for us out of the box. And you'll see that in these topics. Okay, so number one, authorization. What is our authorization story? I actually think this is one of the most interesting pieces of kind of these four problems within what we'll discuss today, because GitHub is a public API, and as a result, we have to solve for a lot of cases that perhaps other companies don't. So we use GraphQL Ruby. That's kind of the gem that we pull in for GraphQL. And we hook into the .authorize method in GraphQL Ruby. But actually, before I go on, I just want to say that GraphQL Ruby has really good docs. And if you want to read more about its implementation or authorization within the gem, definitely recommend taking a read. So we hook into the .authorize method. And from this call, we kind of shoot off two different calls. The first is typed can access, which isn't super readable because this is literally pulled from our code base, but this is basically an API access check. And then the second bolded line, typed can see, is where we do our viewer access check. So I'll talk about both of those, and let's start from the inside out. The view access check is run on every single object before it goes out. So that might be from an API request. It might be from within the Rails app. If we're rendering some sort of data in a view, that's also going to pass this check. This is on every single object. And it's kind of like our last-ditch effort. Really, a lot should have happened prior to this check to make sure that data isn't going to the wrong hands or that unauthorized viewers aren't seeing a particular set of data. But this is like the final line in the sand, really before it goes out to the viewer. Can we stop any last issues? And it's going to look a lot like any other authorization. It's got business logic in it. It's probably pretty familiar. This is on a user object. As you can imagine, you can pull up the profile of any GitHub user. So it's a very simple hard-coded true. And these can start to get more complex. Like if we have an issue object, we have to check a couple more things. But really, the important line is the deepest nested line, which is, can this issue be read by the viewer in this context? So this check actually can raise. Like I mentioned before, there should have been a lot of filtering happening prior to this last-ditch effort, whether that's an Elasticsearch filtering or if that's just through us using the associations that Rails gives us, an active record gives us. So if for some reason some data got through to here, we really need to be worried about that. We need to be fixing that as a problem. We need to be prioritizing that fix. So this raises instead of returning anything, which isn't necessarily the best experience for someone that's querying the API and has no idea what's happening, but at least it means that we're not leaking data. And again, this is that first code block that I showed you, literally from our code base, and there's that viewer may not see error. I'm not going to lie to you, we're not perfect. We have a lot of these sitting in our error monitoring every day, and we kind of slowly make our way through them. So the API access check, which is kind of the first check that's performed, this is the one that isn't necessarily as common because this is for our public API. And there are so many myriad different ways that people can interact and authenticate with GitHub. A lot of these you're probably familiar with, things like personal access tokens. And personal access tokens can have a set of scopes applied to them so that any PAT that you create doesn't have access to all of your data on GitHub. There are things like GitHub apps. There are things like OAuth apps. There's this thing called an OAuth app access policy, which if you work with GitHub in your organization, you might be familiar with it. It's basically what allows me to use one single GitHub account between open source, between kind of side projects, things like that, and what I do for work. Because if I wanted to let some sketchy OAuth application access all of my private repositories, like that's my prerogative. But if I didn't do the due diligence there, that shouldn't affect all of the organizations that I belong to. Because GitHub security team's due diligence process is a lot better, as it should be. So just because I give an OAuth application access to my private repositories doesn't mean that it should have access to all of the repositories of all of the organizations that I belong to. That's what that is. There's also SAML. There's just a lot going on, and that's a lot to keep in mind when you're trying to write authorization checks. And if you can't clearly understand what your authorization check is doing, something wrong is probably going to happen, and we don't want to do that. We don't want for that to happen, that is. So this was actually, the GitHub solution to this wasn't specifically built for GraphQL. It was something that was already existing for the REST API because all of these methods can be used to authenticate against the REST API that was already existing before GitHub had adopted GraphQL. But we created a DSL for this, and this DSL is actually, I think I tried to pull up the repository, and it goes back pretty far to, I want to say like 2012 or something. So I'm going to just walk you through this particular set, which is nice and a little bit of a leaf node, so hopefully it's clear to understand. We do role-based access control here at GitHub for most things, which means that we define a couple of roles, and then we define an access, and we say, if you want to do this action, you must at least fit one of these roles. So in this case, we have a role called everyone, which is true for everyone. If you're using the API, you're part of everyone. Then we define something called a deployment lister, and this is where we say this role requires a scope called repo deployment, which is one of the scopes that you can apply to a personal access token. And within that role definition is where we say, or where we put the business logic of what makes someone a deployment lister. Then we define the access itself, and this is kind of like if you were to think of authorization against a REST API, I personally think it's a little easier to reason about because you have things kind of narrowed down to the action. So the list deployments is essentially a get, and it's an action. So this access is kind of how we authenticate against, or sorry, not authenticate, authorize against that action. So in this case, as you can see, if the repository is public, then everyone is able to see it. If it's, well, whether or not it's public, a deployment lister is able to see it. And because we've put all of that logic, all of the complexity of what that role entails and what access allows that role, in the code itself where we're doing the API access check, we don't actually really have that much business logic. All we have to do is check against that defined access, and we have to kind of pass it all of the things that are necessary. We have to pass it something like an org to ensure that we're enforcing access policies. We have to pass it things like our integrations, which is basically like our GitHub apps, our bots allowed. But in the object code itself, in this particular check, there's really not a ton of complexity. So that's great. That was already existing for REST, and we got to reuse it in a lot of ways for GraphQL by kind of hooking into this particular authorization method. And because it's really hard to reason about this when you're writing it, it's also really hard to reason about this when you're testing it. There's no way that I'm going to sit there and write like every single condition for every single scope possibility or scope combination possibility. So we also have a DSL around testing, and this was also something that already existed for REST, but the API team worked really hard to make it work for our GraphQL API as well. So this is kind of what it looks like bare bones. We're able to see, well, are we allowed, or for a given field, can we allow, forbid, and reject a certain set of users, a certain set of bots, etc.? And here's an example of that being used. We're querying against a node that's a user, so it's an object query, and we're saying the default is anyone is able to access any field with no scopes, with no particular scopes. So this isn't the full matrix that's going to be built out with this test, but this is kind of an example to give you an idea of really what's happening here. And if I had to write this by hand, it would literally be like 6 test cases, and that's not fun. So I'm really grateful that this DSL exists. And then we might have something just a little bit more complex, like who can query the email field on a user? Well, only the user is ever allowed to do that, and it requires certain scopes so that not all personal access tokens that this user has is necessarily allowed to access this information. And here's an idea of what that matrix looks like. So this is really where the complexity comes in. Even if I was to go and write 6 test cases for this particular field, that is, it's very likely that I would miss one of these, and this doesn't even include all of the different scopes that could be granted and all of the different kind of app-bot integration combinations that could exist. So that's our authorization story. We have these 2 authorization subchecks, and we also have a great DSL in place. Number 2, server efficiency. How do we deal with that? So server efficiency is actually one of the reasons that GitHub adopted GraphQL in the first place. It's really hard to solve the problem of N+1, making sure we're only making performant queries and we're only ever fetching the minimum set of data that's needed to render a particular view or to respond to an API request. So the idea was bringing GraphQL in would really help solve some of these problems. And we rely on a lot of open source to do this. We use GraphQL Ruby, like I mentioned earlier, by a wonderful fellow GitHubber, Robert Masalgo. We also use the GraphQL batch that was built at Shopify. And both of these things, or both of these gems, kind of give us something called lazy execution. So what this says is instead of running a query or fetching a piece of data as we're using it, which is really how those N+1 queries start to become a problem, instead we're going to batch all of those requests together and fetch them all in one query. And then instead of potentially throwing those results away or not reusing those results. We're going to hold them in a cache. So within one particular request, no object should be fetched twice if everything is going well. That's lazy execution. You can also read more about that in the GraphQL Ruby docs. And because we're building on, we're really standing on the shoulders of open source giants here, we don't have to do a whole lot here. This is what our user email preloader looks like. And if you know the Facebook setup, these gems to GitHub are kind of like data loader to Facebook. So we're saying, well, I want to load a user ID, but instead of that happening immediately, that's going to get batched into a set of user IDs, and then we're going to run one query to fetch all of those at the same time. But loaders don't help if we're not using them. So because we're a Rails shop, because we're very Ruby friendly, a very Ruby-esque way to do this, we also kind of meta-program so that we're building a lot of helper methods. So instead of having to remember to go and call the loader every single time, when I'm accessing an object like a repository owner, I can just use this async method. It's an async prefix, and that means that it's going to be fetched through a preloader. But even still, maybe this is too much friction. Maybe you're not going to remember to do this. So if I didn't use this block, if I directly went and accessed repository.owner within the scope of a GraphQL request, we have some linting in place for that. We have tests that basically catch direct association accesses within a request. And before you can even do the deploy, before you can do the merge, somewhere in CI it's going to tell you, it looks like you're in a GraphQL request and you're trying to access an association. Do you maybe want to use the async helper? Are you sure you don't want to use a preloader? We really think you want to. So this helps a lot. Using all of these tools together means that when I'm building a view or something like that, I really don't have to think too much about server efficiency. I don't have to think too much about N+1s. Obviously, there are ways to abuse that, and that's on me as an engineer, but there's a lot of friction taken away. Number 3, results caching. We don't do this at GitHub. Yeah. OK, no, but actually, we don't really do this at GitHub, and it's a really hard problem to solve. That's certainly one of the reasons. Figuring out how to cache results for GraphQL queries is not trivial. But on top of that, just like how GraphQL was built to solve a particular set of problems at Facebook, when GraphQL was adopted at GitHub, we really had to make it work within our services. And GitHub has never had a super compelling story around results caching, even for our REST API. It's just always invested more in a fleet of read replicas. So we still don't have a great story for results caching, and I'm not sure that we're going to invest in it anytime soon because what we have works for us. But if you have a really great way to solve this problem, I would love to hear about it just out of curiosity. And finally, number 4, rate limiting. I'm not going to spend a huge amount of time on this because we actually have really solid public documentation about rate limiting against our GraphQL API, and it even has sample calculations. So everything that I'm about to say is pulled from this website. You can definitely take a look. Maybe you have to take a look if you've hit one of our rate limits. So obviously, GraphQL rate limiting is a very different beast than rate limiting within REST APIs because the variance of a query can be so high. You can fetch one field, or you can fetch literally every single thing that you have access to within GitHub. And those are very different things that shouldn't be weighed the same. Actually, the latter really shouldn't be allowed. You shouldn't do that. So we have something called the node limit, and the node limit is 500,000 nodes per call, which I just think is funny. That's such a high number, like I can't even conceptually think about it. The way that we calculate nodes, well, nodes are hopefully familiar within a GraphQL context, but every kind of entity that you're calling is going to count as a node, and we have the sample calculation up. This is on the easier side of calculations. You can take a look on our docs, our public docs, for a more complex calculation, but you're not going to be able to run something that's going to fetch more than 500,000 nodes. Then we have something called a rate limit, and I believe our rate limit on the REST API is something like 500 calls per hour, sorry, 5,000 calls per hour, and on the GraphQL API, it's 5,000 points per hour. So I think that this is way less intuitive than the node limit personally. If you can look at this query and figure out that the score is gonna be 51, good on you, but that's just not intuitive for me. So if you want to see how that number comes about, you can take a look at the docs again. But basically what we're trying to do is we have a heuristic that wants to kind of estimate what the load is going to be like on our servers. And it's really looking more at kind of associations as opposed to the pure number of nodes themselves or the number of fields that you're interested in. So that's our scoring. And when you're interacting with a REST API, if you want to know how you're doing against the rate limit, you can usually fetch that information from the headers. So for our GraphQL API, we've also built in this rate limit field, and that's where you can poll and ask, like, how am I doing? How am I doing? But maybe don't constantly poll because then you'll waste your points. But here's what that looks like in a query. You can kind of see what's the cost of the query that I'm currently running, how many points do I have remaining, when is that going to reset. If you're running against our rate limits, this is definitely something you should look into. And that's pretty much it. That's how we handle authorization, server efficiency, result caching, and rate limiting, or rather how we don't handle result caching. Hopefully that was helpful. Hopefully that inspired some sparks in your mind. If not, that's cool too. Let us know what you do. Let us know if you think that there are glaring flaws in some of our approaches. And that's all I have. Oh, also shout out to my wonderful colleague Mark, who is a bit of an internet celebrity within the GraphQL world and helped me go through these slides.
I'll take one or two questions. Any questions from the audience?
Your authorization checks sounded kind of like all or nothing, like you shouldn't even be asking for something that you don't have access to. Did I understand that correctly?
You shouldn't even be having access to some.
You should be asking for something that you don't have access to. It sounded like it would raise an exception and blow up.
Right, okay, that's actually a great point of clarification. So the question was kind of about, like, if you fail an authorization check, does the entire request blow up? Am I understanding that correctly?
Yeah.
Okay, perfect. So the viewer access check, that is true because that's where we do a raise. But if for some reason you fail part of the authorization check within the API access, that actually doesn't. It fails silently. And error handling is also one of those things that's not super, that GraphQL is not super opinionated about. But if you're fetching a huge request and you failed authorization on like literally one field, then we probably don't want to bomb the entire request. So if the API access check failed, then we'll basically nullify that object. So instead of seeing any of the fields, you'll see an empty object or just a null string or something like that. But the viewer access check, that one's a little bit more concerning for us because those go straight to our views as well. And we really don't want to be rendering information that's not working. And we also don't want to not fulfill kind of what is expected of the GraphQL response because then our views are going to have problems loading.
All right, any other questions?
I had a quick question. Do you serve different schemas to different people? And if so, like, how do you control access to who sees what fields and what schemas?
Yeah, okay, so that's a great question. So we do have a concept of visibility because especially with a public API, if we're building things pre-launch, if they're only ever supposed to be consumed internally, then those go into our internal schema. So we kind of have these 4 giant schema docs because we also do have a enterprise server product. So we have like a public and an internal schema for our public.com offering, and then we have a public and internal schema for our enterprise offering, which because of the release cycle might be a little bit different. Aside from that, there's not necessarily a lot more because part of kind of the GraphQL spec is that you shouldn't need like 20 different schema files. You should just be selecting what your using from the schema, and that should fulfill whatever your needs are. So the idea behind that visibility for us is really more making sure that people who aren't supposed to see a field can't see it. If something is in beta, you need a feature flag to be able to see a field. If something is, we have this great thing called preview, which is our way of rolling things out without fully committing to them, because we don't want to break your APIs in the future, especially when it's a public API and we don't even know what all of the consumers are, or we don't know what all of the potential use cases are. But yeah, it's these 4 main schema docs.
Thank you very much.
Thank you.